Hello, everyone. Welcome to the Applied HPC seminar series. Today, I'll be talking about model evaluation with Tensorboard for healthcare applications. Model evaluation is crucial in healthcare AI to ensure reliability and safety. It's important when you're training models to actually verify that the model is learning something. So, for example, with tools like Tensorboard, we can evaluate the loss, the accuracy, and bias within the model as we're training it live. We're going to focus on utilizing Tensorboard for visualization, and ultimately we'll be showing how you can implement this within your own codes. Tensorboard is an open source tool for visualizing machine learning models. It provides real-time feedback on training metrics, model architecture, and hyperparameters. It's extremely helpful in debugging and improving model performance during training. And it supports various visualizations. So we can look at scalars such as loss and accuracy. We can look at the model structure, and we can look at the weights and biases. It's an extremely usable tool for evaluating model performance live, and it's very shareable and loggable. What that means is that we log whatever we want to track over time, and then we can actually share those logs or utilize them later for evaluation. So it's extremely simple to set up your environment to work with Tensorboard. So it's as simple as just installing the requirements, including Tensorboard. For today's demo, I'm going to be talking about utilizing this within Torch and Torch Vision. To set up this environment, assuming you have a Conda environment set up already on our CHPC, you would just do pip install Torch, Torch Vision, and Tensorboard. Some key metrics for healthcare models to evaluate are accuracy. So you want to make sure that the overall correctness of your model is ensured. You want to evaluate the precision, which is the proportion of true positives among positive predictions. You want to look at the recall, which is the proportion of true positives among all actual positives. The F1 score is so very useful. So it's the harmonic mean of the precision and recall. The ROC curve is very useful as well because it provides the ability to distinguish between classes. It's good just to see that the ROC curve is approaching 1. The confusion matrix is also very useful because it shows correct and incorrect classifications and is very useful in terms of determining where your model is making mispredictions. So when you log metrics with PyTorch and Tensorboard, it's extremely easy. So here I have an example, just pseudocode training loop where we're just adding a couple of scalars to the writer. Basically, we define a writer, and within the training loop, we can keep track of anything really. Here, I'm just adding loss from the train and accuracy from the train to the writer. Very quick, very easy, minimal code. Beyond that, we can visualize the model architecture. Visualizing the model architecture is important because it helps us understand the model complexity, and it helps us identify potential bottlenecks or errors in the architecture. It's also useful because ultimately, if you want a generalizable solution, it often makes more sense to utilize a smaller model as opposed to a larger model. You want to utilize the smallest model possible to capture all of the variance of the data. If you use sufficiently large models, you can overfit. So Tensorboard is also useful for hyperparameter tuning. So you can log stuff to the hparams dashboard. You can also utilize determined AI for automated tuning. Today, though, I'm focusing on Tensorboard, but you can define a search space within the YAML configuration, and you can ultimately explore various algorithms. So you can utilize a random hyperparameter search, a grid, or Bayesian-based hyperparameter searching. So in some sense, it's similar to RayTune, although it's pretty simple. Both methods are fairly simple. So it's important to visualize your model performance. So you want to plot the train versus the validation metrics. For the confusion matrix, it's useful to utilize sklearn or otherwise to use Seaborn to visualize that. ROC curves are also very useful to visualize and should be visualized whenever you're training a model. And you want to visualize in Tensorboard, or you can export for custom plots. So it's important to actually verify the outcomes of your models. So you can generate all of the figures that I've talked about previously. You can also identify or analyze the bias. So you can track the performance across different demographic or medical groups to identify bias in the model predictions, which is also very important. You want to visualize some of the sample data as well. That's just kind of like a sanity check that should be done at the beginning of training every model, just to verify that you're utilizing quality data. And it also makes sense to monitor custom metrics. So, for example, you can have healthcare specific metrics like survival probability, disease progression, etc. And you can do all of that within Tensorboard. So this is an example of what a run would look like within Tensorboard when you're looking at the test accuracy and the test F1 scores. You can add as much as you'd like to the logging. And let me actually share my screen and show an example code where I've implemented this. So I'm going to go through a code that I've generated for utilizing Tensorboard profiling within an example code that we've utilized before. This is the explainable AI for healthcare imaging demo, which I've shown previously. I'm just going to walk through how to implement profiling within a similar code. So here I have the setup of the code. The main difference is we're installing Tensorboard here. What we're doing is we're pooling the data set. So I'm using the chest X-ray data set that I've used previously. We're defining the model and the training function. And actually within here is where we're adding the lines that we need to log the scalar. So we define the writer here at the top. So it's as simple as defining the writer and then ultimately logging whatever scalar metrics or whatever metrics you would like to add. So I'm adding some scalars and a histogram here and images and text. So it's very simple to add this to any code. I've made minimal changes to the original code here. And then from there, you can actually train the model, evaluate the model, and then I still have model interpretability with Captum. But the main thing is at the very end, you can view the Tensorboard logs. So here I'm just loading the Tensorboard session, and then I'm launching with the logged information. So it's extremely simple to utilize this. And once you actually do logging, you're able to generate figures like this automatically, which you can then download and use in your publications or pull the data and replot as necessary. But the main point is it's extremely simple to utilize Tensorboard to log whatever metric you'd like over time. And I have this example code, which I'll be sharing with everybody. It'll be available in our GitHub repo later today. But ultimately, that's it from my side. If anybody has questions about utilizing Tensorboard, I'm happy to answer. And besides that, if you don't have an account already, I would ask that you create an account on our CHPC. We have free GPU and free CPU usage, so it's a good way to get started on any project. And if you need more help, like if you'd like somebody like myself to sit down and actually walk through your code with you and help you get started, you can scan this QR code or email me directly, and we can set up a session to walk you through how best to utilize profiling either with Tensorboard or Determined AI. And if you're interested, please sign up for the next seminar. We're constantly putting on seminars on topics that are most relevant to users, and we're happy to take any suggestions for future seminars as well. So with that, I'm happy to take any questions from the audience. All right. Well, if there's no questions, thank you very much. I really appreciate your time, and this video will be available on YouTube. The code example will be available in GitHub. And